Hi, Honors Geometry people. Today we're going to take a look at how to prove quadrilaterals are parallelograms. And that's going to go along with our essential question, how do I know if a figure is a parallelogram? As you are watching this video, I'm going to give you some prompts to pause the video, try out the problem, and then compare. You will get the most out of today's video if you do that, because it's super easy just to watch somebody else do a math problem and think you have it, but make sure you try it, and then you can figure out where you're getting stuck along the way and know how to ask questions. All right, entrance question here. All right, okay, so if we're dealing with angles in a parallelogram, we know angles in a parallelogram, we know opposite angles are congruent. We also know that consecutive angles have to be supplementary. Okay, so those two pieces next to each other, and I'm taking a look at B and C. And I'm going to take a look at these two because these are both in terms of x. So I know those two have to add up to 180. So if I know that x plus 4x equals 180, I have an algebra equation that I can solve. So 5x equals 180. I'm going to divide both sides by 5. And I have 36 degrees for x. So that means that B is 36 degrees, and C is 4 times 36 degrees, so 144 degrees. And opposite angles are congruent, so I can fill in those values as well. All right, continuing on. We know that parallelograms are four-sided shapes, so quadrilaterals where we have opposite sides of parallel sides. And last time we talked about some of the properties associated with parallelograms. What we're going to look at right now is if these four things, like if you look at them individually, if this is all you know about a figure, it's enough to say, yep, it's a parallelogram. Okay, so looking at number one, if we know that the diagonals bisect each other, so remember diagonals connect two non-consecutive vertices. Okay, if this is all we know about a figure, then we can say, yep, it has to be a parallelogram. Okay, if we know that one pair of opposite sides are congruent and parallel, if that's all we know, we can say for certain that it is a parallelogram. If we know that both pairs of sides opposite each other are congruent, that's enough to say all by itself that it's a parallelogram. And if we know that both pairs of opposite angles are congruent, that's enough to say that we have a parallelogram. So think of these kind of like our triangle congruent shortcuts from last time. They just don't have fancy names like SSS and SAS. We would actually have to write out. We know it's a parallelogram because the diagonals bisect each other. Okay, so it's a little bit more wordy, but that's okay. All right, so we're going to try some things out. So example one, I would encourage you to pause the video and then we'll compare, decide if you know this is a parallelogram based on the information given. Okay, hopefully you paused the video. We know that EF is congruent to DG. We know that EF is parallel to DG. I would highly encourage you to make up those markings so it's easier to visualize. Okay, I notice that I have one pair of opposite parallel and congruent sides. That was on my shortcut list, so I would say yes, it's a parallelogram because it has one pair of opposite and parallel sides. Okay. Continuing on, let's try it again. Try out example 2, pause the video, and we'll compare. Hopefully you paused the video. Okay, we are given that ED is congruent to FG and that EF is parallel to DG. Now, these are properties associated with the parallelogram. We know we need to have opposite sides that are parallel and opposite sides that are congruent, but this was not on our shortcut list. So we would say, no, not enough info. Okay, so this might be a parallelogram, but it's not enough to say for certain. Okay, let's think about it this way. We know this diagram might not be drawn to scale. It is possible to draw a figure that has a pair of opposite parallel sides, and the other sides, opposite sides, are congruent, and it looks more like this. Okay, so if we look at a figure like this, that's an isosceles trapezoid. It looks less parallelogram-y. Okay, so something to keep in mind. All right, example 3. Here we are being told that ABCD is a parallelogram. We want to find the values of x and y. Again, pause that video and we will compare. All right, here's a hint if you're stuck along the way. We know, since the parallelogram, that those diagonals bisect each other. Okay, so if you were stuck, that's your hint. See if you can write 2 little equations to solve for x and y. Okay, so let's try it out. We know that CE, this top piece, is congruent to EA, this bottom piece. So we can write the equation for x plus 1 is equal to 3x plus 4. Okay, we need to get x all by itself, so I'm going to choose to subtract 3x on both sides. So that gives me x plus 1 equals 4. I'll subtract 1 on both sides, so x is 3. It's so much fun, I'm going to do it again. So left-hand side, that's y plus 6. Right-hand side, that's 3y minus 4. It's super nice that both of these equations just involve one variable. All right, so I'm going to subtract y on both sides to gather my y's. I will add 4 to both sides, so 10 equals 2y. Divide both sides by 2, and y is 5. Shrink it down to give myself some more room for that next problem. Okay. Checking out the next one, we're asking ourselves, is ABCD a parallelogram? All right. The only thing that we know for certain is that this figure has 4 sides. So keep that in mind, pause the video, and decide, is this a parallelogram or is it not? Okay, so the only thing we know for certain is that we have 4 angles. Figures that have 4 angles add up to 360 degrees. So x plus 2x plus 2x minus 60 plus 2x equals 360. Combine some like terms here. So we have 7x minus 60 equals 360. Okay, I'll add 60 to both sides of my equation. So 7x equals 420. Divide both sides by 7, and I have 60 degrees for x. Okay, fantastic. I was able to successfully solve for x, but that doesn't answer my question. We want to decide, is this a parallelogram? So I'm going to plug it in. It looks like we have some angle stuff here, and if we can say that the opposite angles are congruent, then that's enough to say that we have a parallelogram. All right, so angle C is just x, so that's 60. B is 2 times 60, so that's 120. D is 2 times 60, or 120. And then we have 2 times 60 minus 60, which also gives us 60. Since our opposite angles are congruent, we know we have a parallelogram. Okay, last but not least, we have a proof going on here. And at the beginning of class, one of our shortcuts was that if we know the diagonals and parallelogram bisect each other, it's enough to prove, or it's enough to say that we have a parallelogram. Now we're going to prove this theorem. Okay. So if you are not proving the theorem, you can always use this without having to do all the other work along with it. All right. So if AC and BD bisect each other at point E, bisect means it cuts it into 2 equal pieces. So I'm going to add to my proof that BE is congruent to DE, and that AE is congruent to CE, and that's by definition a bisector. Okay. Looking at this further, I notice that, hey, these are vertical angles here. So I could say something like angle AEB is congruent to angle CED because vertical angles are congruent. Okay, now looking at this left-hand side and this right-hand side, I see we have some SAS going on here. So I can say that triangle BEA is congruent to triangle DEA. And since I know that those triangles are congruent, I can say something like AB is congruent to CD because of CPCTC. Okay? I can also say something like angle BAE is congruent to angle ECD also because of CPCTC. And because those two angles are congruent, I could say that AB is parallel to CD by the converse of alternate interior angles. And last but not least, I can say that ABCD is a parallelogram because it has one pair of opposite and congruent sides. All right. Please check out today's homework. It's hanging out in the book. Be ready to ask questions, and I will see you next time. Bye.